Okay, so in this video, I just want to focus on level curves. So what we have done previously, when you can see the level curves, when you want to do a trace, right? Especially on y-axis plane. So what you have to do to provide the level curves? So you have to equate the z by specific constant value. So the constant value here can be positive, can be negative as well. So depends on the expression given to you. So if you look at the expression given to you that z can be negative, so meaning that z can be negative. But if it says that, for example, z equal to, and the equation is this one, so it cannot be negative because we know that on the right side here always give you a positive, so z cannot be negative. So when you put z negative, so it's mathematically wrong. Okay, so I would say that, let's say you put -1 and equal to x squared plus y squared. Is it mathematically correct? Okay, why I'm asking like that, because you just look at the expression here. For whatever value of x that you choose, the value for this term always positive, right? And at least the smallest one is 0. Similarly, you can put any y, you can put negative, you can put 0, you can put positive, and the answer for this term always positive. So when you total up the positive numbers, so the answer here can be also always positive, but the smallest can be 0. So on the right side tells you it is negative, so it is mathematically incorrect. Okay, so you need the level curve when you sketch the surface, especially when you have the equation, and the equation contains the total number of variables is 3. Okay, but it's not necessarily like that. But normally, for the, I mean, by hand, you always see the level curves when you sketch the variable that there are 3 variables there. I mean, when you want to sketch an equation where the total variables 3, but it's not always like that. So what is actually level curve? So in other words, sometimes when you refer other book or other references, they use the word of contour curves or contour map. So it depends on the book that you have. Okay, for example, you have so what is the idea here? So this, imagine you have a mountain. So you have the 5,000 feet, 6,000 feet, and at this level 7,000 feet, 800 feet, and you have the peak here, right? So imagine this is the function of two variable function. So when you are watching, you are inside the plane and you're looking down, you cannot see this mountain right from the above. When you're flying, just like bird, you just flying over here, you cannot see this kind of shape. Then what can you see is just like this contour. Okay, so that's why I put here bird's eye view. So when you are inside the plane and you're looking downward, and you can just see this particular shape. So this is the idea of level curve or contour map or contour curves. Okay, and also this one, you have a mountain, you have a groove here, and you cannot see all these things when you are in the plane. What can you just see is this one. Okay, so let's say here sometimes it's quite hard for you to differentiate which one is the peak and which one is the groove one. Okay, when you are in the plane, isn't it? So how can we sketch the level curve? So I don't want to explain this, so we have done that. So it's just the idea. Okay, and we have done sketching the this is ball. Okay, and this is cone. I know that majority of you confused. How can we have okay, how can we have, for let's say this one on the z-axis plane, on the z-axis plane, which means that when you replace y equal to 0, so that is about trace, yeah. So z equal to, so this is the original. So what if you want to sketch a surface, you have to look at the original one, not after you modify. So this is the given one. Okay, so this is the given one. So meaning that when you want to provide this the trace, so let's say you want to sketch the trace y equal to 0. So you replace y equal to 0 and you will have this particular form. So I know that after you simplify, you will get this one. Okay, that is after simplification. Because we want to get idea what is actually the shape looks like. It should be a straight line, okay, a straight line. But then you have to look at the original here. I mean here, the original here. So investigate. Try to stare this expression a bit. Okay. So you have the square root, meaning that z always positive. So your sketching should be over here. Okay. And then look at the y squared. So now just narrow down. Okay, just thinking about the y here. Ask yourself, can y be negative? Yes. So again, so zx meaning y equal to 0. This one supposedly, I'm sorry about that. Sorry. So this one supposedly x, okay, x squared, and this one should be x, okay. So now x can be positive. You're thinking about the value in the square root, okay. And this one, after that, whatever x that you choose, whatever value on the x-axis, it should be no problem. Okay, why I'm saying like that? So if you put the x negative, also possible, because when you put -1 and then you square, so 1 square root still give you a value of z, isn't it? So let's say I'm choosing -10. So -10 square, will give you a positive number, and then you can obtain the square root, still real number. Okay, so what can you, so okay, it looks like we have a straight line, yes, but it cannot be, you cannot extend till here because z always positive, so we just ignore this. But you want to say that x also can be negative, right? X can be negative. So what is the shape looks like? So x negative means that the gradient can be also negative about the x, right? So we have this particular shape. Because for whatever value of x, okay, for whatever value of x, I mean x is so negative, so it turned out to be z is always positive number. So that is the idea. But if you provide me just this one, is that correct? Because now you look at the original again. X can be positive, x can be 0, and x can be negative. So meaning that you have to consider the second quadrant as well. Okay? The second quadrant as well. So when the second quadrant, you must have the continuous line. So you cannot provide me like this. So it's not possible. You must have a line which is continuous. If you provide me this particular line, so it is not continuous with the quadrant 1. So you have to draw like just like you have the absolute function z equal to x. So what is the graph of this? You will get the similar graph here. So what is your justification so that you can have this? It is because you want z always positive. Yes, z always positive because you put absolute, right? So z positive. And then what is the value of x that you can put? I can put x negative. I mean, z can be negative x and z can be x. So this one for positive gradient and this one for negative gradient. Or maybe to satisfy you, so we can also write down like this, because this is the original one, right? We want x to be at the end to be x squared. Then this is the original one, x squared. Okay, but then you can put any value of x inside here, and then you put the square. Okay, so it end up to be this one can be cancelled out. So square root and square cancel out, so you have minus x and you have x. Okay, so but this is after you simplify, because we want to look at what is the graph looks like. But you have to refer back to the original expression where here we want the z always positive. So you have this kind of graph. This positive gradient, negative gradient. So this is z versus x. But with the condition z always positive, just look at the original expression. So we have to just consider you have to consider the first and second quadrant only. So because we want z to be always positive. So hopefully you clear with that. Okay, here I will share this in the e-learning so that you can try yourself, reproduce them yourself. I think it's already been been discussed in the notes that I give you, the lecture note that I give you previously, but maybe there is no specific explanation on the level curves. So I will share with you this in the e-learning. And I give you another example here. So first I want to say sorry because I give you the sketching by hand, because I am asking you to sketch by hand, so it is to be fair, right? Then my answer also sketch by hand. But this one is something, it's not easy to be done, but you can try. Okay, so that is for level curves. Okay, so what I want to say here, these are some example that we want to know how to sketch some particular surfaces. So I would say that most of the surfaces that we have out there is very complicated to be sketched by hand. So the thing that we sketch, for example, we have ball, we have cylinder, we have paraboloid, we have hyperboloid, we have sphere. That's something that we can sketch by hand. So just keep practicing on this particular example, especially when there is something shifted along x, along y, or along z. You have to be aware with the equation given to you. Okay, maybe I want to show you another example on the next video.